Hey, Vlad here from devinside.com. Welcome to another video. The first couple of seconds of a YouTube video are the most crucial ones. They're supposed to hook the viewer into the rest of the video. But I did something so weird that I don't even know how to describe it. So let's roll the intro and hope for the best. Now, in case you're new here, I would like you to know that most of my videos are from scratch. We create a project based on one of my generated templates, we write some code, we learn something new, yada, yada, yada. Today, we're taking a slightly different approach. I've created 4 versions of the same tiny application, and I will tell you all about it right after today's sponsor, which is you or people like you. We're currently on the road to 500 patrons or GitHub sponsors, whichever you prefer, so please consider supporting this channel. All your donations will go right back to it. I'm currently searching for a video editor that will free up my time. Instead of editing videos, I will spend my time with you, whether it's during live streams or support sessions or even game night. So every patron counts. I have been obsessed with the topic of software architecture for many years, and unless you're new here, you have seen many videos related to architecture, and one day I'm planning to create an entire course about it and maybe even write a book. Obviously, we're not going to go through the entire architecture today. The most important 2 things to understand about it is that A, to me, architecture is all about managing dependencies, and B, whenever I create a project, no matter how tiny, it's usually separated into several submodules, usually at least 4, and at the top of them is the core submodule or subproject in SBT, which only contains the business logic. So there's no JSON, there's no database, there's no networking, there's nothing, just the business logic. Now it all sounds fine and dandy, however, there is a catch. What about the third-party libraries, the third-party dependencies? Can I push them completely out of my core? And if my core has absolutely no dependencies, then what about the standard library? Can I push the standard library out of the core so that I have just my code? And so this is exactly what I tried, and honestly, I kind of succeeded. The core of one of the versions of this application has absolutely no dependencies. The only thing that I allowed myself to use were the types and the literals of which were built into the language. In a nutshell, I'm talking about the primitive data types like int and boolean, but I haven't used any collections or tuples or anything like that. The only other dependency that the core has, and by the way, it's not a third-party dependency, it's mine, is just another submodule with a bunch of traits, but the implementations of those traits are somewhere else, and I'll show you everything in a bit. Now, I always wanted to try this, and for some reason, it has always been clear to me that the solution to this, or the path to this, are type classes. And so what I ended up with was the most extreme version of effect tracking, even though my application didn't have any side effects to begin with. I mean, sure, at the end, it prints out the result to the terminal. However, the code that does that is not inside of the core of my application. And so I ended up with tracking, but without effects, if that makes sense. In a bit, I'll show you how extremely tightly typed the core of this application became. However, before we get to that, I would like to be extremely clear about one thing. Under no circumstances do I recommend that you develop your applications like this. Even though I found it somewhat valuable, the cost is so astronomically high that you should be fired if you try something like this at work without permission. It was just an experiment. This is YouTube after all. All right, so let me tell you what I built, because even though I wanted to try something like this for years, I was actually triggered by a real-world problem that I was trying to solve. As some of you might know, I'm a freelancer. My main client is Avantstay, and we're hiring. This video is not sponsored by them, but I get a referral bonus, so please make sure to mention me when you apply. Be sure to check out the details in the description box below. Now, as a freelancer, I need to send invoices to my clients, and the way it works with Avantstay is that we send 2 invoices every month. The first invoice is sent out on the 15th of the month, and it covers the work days between the 1st and the 15th, including the 15th. And the second one is sent on the 28th of every month, and it covers the work days between the 16th and the last day of the month. Now, it's a pretty tedious process, even though obviously I use some invoice generator, but still, even with the generator, it has a form that I need to fill out every time I want to generate an invoice. The project that I built does not automate the entire process. However, it's actually not far from it. For now, it just prints out all the information that I need to put into this form. It's things like the automatically incremented invoice number. Even though the invoice generator increments them for me, I sometimes need to change it. It's the date of the creation of the invoice. It's the due date, which is 1 month from the creation date. It's the amount of work hours, which is 8 hours times the work days. And so the reason I built this app is because every time I need to generate an invoice, I have to open my calendar app and I have to manually count the work days, either between the 1st and the 15th or the 16th or the end of the the current months. I usually do this once a year in the beginning of the year, just generate all the 24 invoices. And this time I almost fell asleep. And in fact, after I built the app, I realized that I actually made a couple of mistakes. All right, and so there I was. I hacked this program together. It took me like half an hour. It was like 100 lines of code. And I used the Scala CLI for it, by the way, and I have a video about it, so you might want to check it out. Now, what triggered me was the fact that I had to work with dates. And even though I didn't need to worry about times or time zones, still, occasionally I had to look up the Java time API, and I had to kind of like stop and, interrupt my thought process. Occasionally I would put like a private dApp that would do something for me, and I would just put the 3 question marks so that an exception is thrown. But still, eventually I would need to go back and actually look it up. In fact, when I was writing the script for this video, I realized that I should have used the GitHub Copilot. It was a perfect use case for it, and I have a video about it. You might want to check it out. Another thing that bothered me is the fact that I was kind of lucky that the time API was included in the Java standard library, which wasn't always the case, by the way. The Java was notoriously known for having a horrible time API, and so everybody was using Yoda time. But since Java 8, I believe, it actually has a decent API. And so what if it wasn't? I would have needed to like stop and search for an API, learn the API, etc., etc. But I shouldn't need to do this if I'm writing the core of my application, right? It's the business logic. It should not have any implementation detail of some library, even though it's just a library and not some, I don't know, database driver or something like this. All right, so let's start by walking through this hacked version together, okay? So I'm on Windows and I'm using workspaces, and today we're going to use a bunch of them, okay? So this is the hacked version. Then these ones are, is the rewritten version, the one is that it's rewritten 4 times. So we're going to talk about it just a little bit, just in a second. So let's switch to this one, okay? So this is the hacked version. Therefore, it's like basically one file, and I use the Scala CLI to run it. It's like around 100 lines of code, and we're just going to walk through it real quick. Okay, so as already mentioned, I'm using the Scala CLI. So I'm using Scala 3.1.1. So this is just a main method. I'm hard coding the year. I'm specifying that the first invoice number is going to be 23 because I started working for Avance last year in February, and therefore in 2021 I generated only 22 invoices, and so the next one is going to be 23. I also have an optional rate. It's optional because it never changes, so I don't need to remember what I'm going to put into my invoice generator, and it will actually calculate how much I earned based on this rate. So I don't need to put it in, and therefore it's optional. Then I have 2 functions. The first one generates the first invoice of the month. The second one generates the second invoice of the month. Okay, and then I have basically a fold. I'm going through a couple of months, right? So through all of the months from 1 to 12, it's just a fold. So I'm collecting the invoice numbers and I'm collecting 2 invoices. Okay, so for every month, I'm generating 2 invoices. Okay, so at the end, this invoices thing is just a vector of invoices. And by the way, it's a vector because I'm appending all the time. I'm concatenating vectors. An invoice is just a case class somewhere at the bottom. It has the invoice number. It has, the date when it was created on, when it was due on, which is just, plus 1 month. It's the, the period, right? So either from 1st to 15th of the month or from 16th to the end of the month, the amount of work hours. And obviously, if I specify my rate, then it will also calculate the amount. Then there's a little bit of code about, about printing, right, rendering. And so after I have my invoices, I just, map them to rendered for each print line. And also if I specify the rate, then I will also display another column. And also at the bottom, I will display the sum. Okay, let's open real quick these methods. There's nothing special about them. So this is the one that goes from the 1st to 15th. I'm creating a range from to get day of month. I'm mapping all of them to local dates, so therefore I have like almost like 15 dates. I filter them because I need to keep only the work days. The work days are the ones that, not Saturday and not Sunday. And then I take the length, right? So I'm counting like how many days are left in this range, and then I multiply this by 8 because 8 hours in a day. Okay, and so the created on for this one is the same as the 2, which is the 15th. Okay, so I'm on the 15th, I'm creating the invoice. Okay, and so I'm just filling out this case class. The due date is just plus 1 month, nothing super fancy. The second invoice is slightly more involved because it needs to calculate the last day of the month. And in fact, this is exactly what triggered it, because it was not a trivial thing. Like I didn't remember how to do this. I had to Google it. The GitHub Copilot would have shown it to me, but I found a solution on Stack Overflow. Okay, in fact, a funny thing, like the first solution that I tried was something that I just had in memory from Yoda time. So what I did was I just generated the first day of the month, but for the next month, and then it just did like minus months. However, it died when it reached the month 13 because there is some validation in Java time. But in my memory, probably from Yoda time, it was actually rolling over. So if you say that it's going to be like the 13th month, In my memory, I might be wrong. It would just create a first month, right? So it's just going to do modulo 12. In any case, so I'm creating two dates. The first one is the 16th. The second one is the last day of the month. And I'm calculating the hours exactly the same way. Calculating the created on is going to be on 28th, not on the 2, right? So this is like a slight difference. And by the way, I didn't bother like refactoring some, some duplication over here. This is a hacked version. I did not try to dry it out or anything like this. And then I'm generating the invoice the same way. Okay, so let's actually go and run it real quick. As already mentioned, I use the Scala CLI, so I can do something like this. Let's create a little bit more space. Okay, so basically for the entire year, it shows me, okay, the first invoice is going to have the number 23. It's created on January 15th. Its due date is on February 15th, and it's for the work days between the January 1st and January 15th, and I worked 80 hours, right? So 10 days times 8, 80 hours, okay? The second invoice is going to be 24. It's generated on January 28th, therefore the due date is February 28th, 1 month later. It's from the 16th of January to the last day of January. January has 31 days, and therefore it's a little bit more, so it's 11 days times 8, 88 hours, okay? And if I specify the rate, let's go and specify some random rate. So let's do something like, I don't know, let's say $10, okay? Or it's not even dollars, it's just 10, okay? Then we have another column. Let me create more space like this, okay? Then we have yet another column, which, multiplies this by 10, obviously, and also gives me the sum. And I made it a double. In fact, the hacked version, I had it actually as integer. Okay, so again, what triggered this was the last day of the month function, right? Where the hell is it? First, this is the second. Okay, it's over there. Okay, so it's this one, right? So basically stole it from Stack Overflow. It's a bit of a weird API because, creating a date with some random day, right? And then you do like get month, and then you get the length of the months, and you have to also give it the leap year. In fact, when I was writing the script for this video, I actually remembered that, Java time has actually an object called year month, right? So another way would be to do this year month off, and then, the year and the month. Okay, and then you can just get at end of month, which would give you the local date at end of month, and then you can do get day of month. And there are several other versions of how to do this. Like, as you can see, like nothing changed. Okay, so everything is still fine. January has 31 days, February has 28 days, and so on. And then, by the way, the fact that there are several implementations and they're kind of like slightly different. So, for example, if I knew this from the very beginning, right, then I would probably create a function that would just give me like the date at the end of the month, right? So this local date, because this is exactly what I need here. Okay, right? So this is what it does, right? So it does local day.off, year, month, and the last day. So my private def would look slightly different, right? So like my basically it would look like this, right? So if we go over here, right, this is going to be the local date, okay? And I'm just gonna grab this guy and put him over here, and I'm gonna remove this one, okay? So it gives me the local date, and therefore the last day of months, I'm gonna do it like last day of months 2, okay? Then over here, instead of this, I could just do last day of month, year, month, and this needs to be the second version, like this. I actually hard-coded the year, so I just need to do it like this. Okay, so as you can see, like this implementation obviously also works, so it doesn't change anything. However, in this version that I will show you in just a couple of minutes, it changes actually a lot, right? The fact that we're changing this implementation so much changes a lot. All right, so let's get to the real deal. Okay, so what I will show you is going to be a directory that I have over here. Okay, so this is going to be a GitHub repository. Now, I did this sort of thing in the past, so I'm going to be very careful explaining this, even though it should be really obvious. Usually you have one Git repository, it's hosted on GitHub, and inside of it you have one project. This is not the case here. Inside of it you have 4 directories. Each of them is an individual project. So if you're using something like Metals, and if you want to open some of them, you need to open the specific one. You cannot just open this entire directory. Metals is not going to understand it. In fact, I have a video about using a workspaces with multiple roots. And well, basically, it doesn't work yet. Okay, so you need to open it like this, like code, and open A, open B, open C. Okay, I already have them open, right? So this is the A, B, C, and D. Now we will go through them in a weird order. So the way it's written is that A is this extreme version that does not use the standard library. B is a slightly modest version with a couple of workarounds and hacks. C is pretty much the most balanced one. And in C, I'm using the standard library, but I'm pretending like the local date is not in the standard standard library, right? So I'm still abstracting away the local date, okay? And then D is the version that I would normally do at work. It is the, what I'm learned as, as clean architecture. I actually changed it a lot, so I probably should stop calling it clean architecture. I would actually like to coin the term diamond architecture, and then I'll explain it to you one day when I will create this course about architecture. So what we're going to do is we're going to start with D, because this is the most simple one. It's obviously like over-engineered, right? Like this is like basically ready to grow endlessly, right? So this could be like a real production grade project. Therefore, I kind of like over-engineered it. Okay, as already mentioned, I always divide my applications into submodules, and we're going to go through them real quick, even though I discussed them in many other videos. But before that, I would like to just mention in which order we're going to go through them. So we're going to start with D, okay? Then we're going to make the jump to the most extreme version, which is A, right? And then we're going to go to B and C. Okay, so we're going to do D, then A, B, C. Okay, so this is the D. At the top of my application, I have the core, and I started using numbers in the directories. However, in the build, the actual project is called core. Maybe I should actually go there, okay? So over here, for example, the name of the project is core, but the directory is 01. And I'm doing this to denote the kind of like layers of the application. So this is the layer 1, this is the layer 2, this is the layer 3, and I kind of wish that I could flip this graph, which was generated, was Bloop, by the way. Okay, so the core contains only the business logic. Again, remember, this is a version where I'm normally using the standard library. In fact, I kind of want to make it smaller. I want to like fit and then do it like this, and I also want this thing. Okay, so this is the business logic of the application, and these ones are kind of divided into two categories, and I also included the category, some signification of the category into the name of the directory. Okay, for example, this project is called config, but the directory is called 02 because it's on the level 2, and it's also B, right? So there's A and B. I didn't know how to call them, so I just called them A and B. Okay, A are the projects that use the core, they call functions on the core. B are the ones that the core needs to function. Okay, for example, the core needs the config, the core needs the core self. Core self is a little bit weird. This is the one that we talked about in the video about the law of Demeter. The purpose of the core self is to minimize the dependencies between the use cases inside of the core. So inside of the core, I have two use cases. One has a dependency on the other, but you don't see this in the core. Essentially, there is a facade inside of the core. The implementation of the facade is in the core self, and the dependency injection is over here. And so you only see that one use case in core depends on the other use case in core only over here, okay? And therefore you can evolve them independently, and you can keep compiling the core without breaking everything. So if we open the core, we're going to see two use cases. The one use case, I kind of extracted it a little bit out because I wanted to show you that something like whether something is workday is actually business logic, right? Because I don't know, maybe for some companies, people don't work on Wednesdays or something like this, okay? So this is business logic, and I extracted it into a separate use case. And clearly, my other use case, the one that generates all of these invoices, will have a dependency on this. However, you're not going to see it, okay? So by the way, I usually call them boundary because, this is the boundary to the core of my application. You can call them however you want. Okay, so if we go to the boundary over here, the boundary has only one dependency, right? It's the gate, right? And the gate is the facade. Okay, so the boundary is just a trait. It has just one function: generate invoices. You give it the year, you give it the first invoice number, you give it the rate, it generates a bunch of invoices. Not such a big deal. Okay, the rest of the file is basically the implementation of this boundary. Okay, in Scala 3, the type over here can be inferred, but essentially this is the new boundary. Okay, so it implements the generate invoices pretty much in the same way as we have seen in the hacked together version. Okay, so there is some range. We have fold left. In the fold left, we're accumulating a bunch of invoices and the invoice number. Or every month, we're generating two invoices. We're using the invoice number +1, and the next one is going to be invoice number +2 because for every month we have two invoices. Okay, generate first invoice. The same as before, just cleaned up a little bit, okay? So for example, over here, we have make dates in order, which is just a private def, right? So tiny range map like to local date, right? So we have a bunch of dates, for example, 15 integers, we're mapping them to 15 dates, to vector. Let's go back. Then we're going through the workouts, right? So we have days, right? Days is simply local dates, right? It's a bunch of vector of local dates. Only work days is just a private extension over here. By the way, it's a really cool thing in Scala 3. The syntax for creating extensions methods is so comfortable, and you can create the defs inside of them as private, and therefore you can write your own code like so, in such a concise and beautiful way. Okay, so I'm doing like days, give me like only the work days, which obviously filters out the non-work days, and then I'm converting them to in work hours. Okay, so only work days is going to be self, filter is work day is something that goes through this gate facade to ask like if is work day, and obviously it will go to this other use case, but we don't see it over here. Okay, and then we do like in work hours, which is just going to take the length and multiply with the gate hours in a work day, and that's pretty much it. Okay, so days last is going to be for this particular use case both the to and the created on, and we're creating the invoice, which is just the case class. Pretty much the same thing as the hacked version. There's also another helper in money, which basically just does rate map times self. Nothing super complicated here. Okay, pure business logic. Okay, so the gate over here is the facade that hides the fact that this information comes from multiple directions, right? So one comes from a config, and by the way, I realized that hours in a workday maybe should not come from a config, maybe it should be injected from the user interface side, right? So from the delivery side of the application. But for now, I kind of left it like this. And this is the stuff that comes from all the other boundaries. For now, I just call it like this. And therefore, in core self over here, I'm going to have the implementation of this other boundaries. And I'm going to say, okay, so in order to implement this, I actually need another boundary, okay? And I'm just going to export the function from there. Okay, so the invoice is just a tiny case class. Okay, so this is the core of the application. Okay, now the implementation is kind of simple. So the implementation of the config is simply going to be, there are 8 work hours in a day. The implementation of the other boundaries I just showed you, it's like this. Okay, now the delivery portion of the application, which is the terminal, it just has one class. I usually call them controllers, not because I'm MVC. Actually, every time I call it controller, I'm actually thinking about a game controller. Like you press some buttons and you call something in the core of the application. Okay, so the only dependency that the controller has is the boundary, right? So because it needs to call the functions on the core application. Okay, so basically it just gets the invoices, gives it all of these dates and does the printout that I showed you. Also, because the case class for the invoices in the core of the application, I created a tiny extension over here to do the rendering, right? So that I can do like map.render. I just, this is just a personal preference, okay? Now in the main, we have 2 use cases and we have DI for those 2 use cases. Like usually I would have an object here called dependency graph, but I realized that in Scala 3, we can have top level objects, okay? So in order to construct the boundary for the second use case, it doesn't have any dependencies, right? So if we go to make, it doesn't have anything. In fact, this could be a lazy val. Lazy val. And this is the boundary, and the dependency injection for the first use case is slightly more involved because it will actually use this boundary. Okay, so it's like this. Okay, so we're creating the controller. The second use case doesn't even have the controller. All the controller needs is the boundary, and this is how we construct the boundary. Boundary at make, it needs a gate. The gate is a facade. The facade needs 2 things, right? So it needs the config and it needs something from the other boundaries. Okay. Right, so over here, this is where you see that the first use case depends on the second use case, and it's so beautiful because I'm using this syntax that we don't even have any imports. And at the end of the world, we have the main, which basically does use case 1 dot controller. And by the way, it used to be dependency graph over here, but again, because in Scala 3 we have top level objects, right? So we can do use case 1, and then I'm just calling the controller, which is just a val that is over here. It's so beautiful, I find it, and then we run it, specify the year, first invoice number, and the rate. Okay, we can obviously run this application, but I'm sure that you can imagine that there's nothing spectacular in there. Okay, so by the way, I have an alias b for bloop. Now again, the main issue that I was trying to solve is that over here in the boundary, like for some reason, even though it's a private def, I have to go and figure out this thing, last day of months. Okay, so I have to have this private def, I have to Google, I have to figure out how to do this with this particular API, and so I wanted to avoid this. Okay, so let's go to A. Okay, so the dependency graph for A looks way more complicated, but it's actually not. It's just that it's drawn in a weird way. So we still have core self, config, terminal, and main, but we also have a third-party dependency. So basically, I pretended that the first of all, that the standard API is not included, and also that the date API is not part of the standard library. And at the top, we have type class. Okay, so we have now this level 0 because it basically has the traits, the type classes. Okay, now over here we have the instances of those traits, right? The implementation. Here we still have the core that now needs these types, right? These type classes. Therefore, it has this weird dependency. Usually, the whole point of this was kind of that the core has absolutely no dependencies. There should be no arrows that go outside of the core, but it's, first of all, it's mine. It's not some third-party thing, and also it contains only traits, right? There's no implementation. The one thing that is not shown over here is that I needed to write the tests for the core. And by the way, I've forgotten to show you the tests, even in the hacked version. I'll show them to you in a second. I wanted to write the tests inside of the core, but when I was writing the test, I actually wanted to use the types from the standard library. And so I did a little hack, and in the build file, I'll show it to you in a second. The test configuration scope of the core actually depends on the compile configuration scope of the third-party dependencies. And I have a video about SBT. You might want to check it out. I'm going to open the build, and I'm going to show it to you real quick. So it's okay. So we have the core over here, and as you can see, it depends on the third-party dependency, but only in the test scope, right? So the test scope depends on the compile scope of the third-party dependencies. Okay, so there's a hidden weird arrow over here, and also I didn't show any of the tests. And by the way, these arrows, they're just drawn weirdly, but essentially everything here has a dependency on the core, and everything here has a dependency on third-party dependencies. Okay, I only pretended that the standard library does not exist inside of the core. Over here, there's nothing weirdly abstract. Okay, let me actually go back and show you the tests real quick. They look almost the same in all of them, but still, that's not what I wanted to do. Okay, so we have the boundary suite. Okay, so the boundary suite is over here. And by the way, recently VS Code has implemented this, and Metal's implemented this as well. So you can press play over here, and it will actually run, and it will turn green in just a second. And let's also open it, and there we go. Okay, so I have a couple of tests. I have 3 tests. Usually the way I write my tests is that I have a companion object at the bottom, and it implements a fake gate, and it's a class because I actually wanted to extend this class. Okay, so it always looks like this, and then in every test I extend the fake gate and I implement only the things that I need. Like in this case, I need all of the things, but still. I also created this like helper method because in Scala 3 this type over here can be inferred, and so I didn't want to write fake gate. Okay, and therefore like this private def thingy is going to help me out. Okay, so basically every test just constructs a boundary. I override these things because this is a facade. So even if you have like 20 different dependencies, well, you're going to have like 20 functions over here, but you need to inject only one thing, which is very, very beautiful. So in this particular case, I'm calculating like all the work days in a leap year. So I'm saying that there's going to be like 8 work days. I'm going to pretend like every day is a work day. Right, so this is not the real implementation of like not Saturday and Sunday. I'm going to pretend that every day is actually a work day, and now I'm going to generate the invoices for 2024, which is a leap year. I'm going to pretend that the first invoice number is 23, even though I don't care about it. The rate is none, even though I don't care about it. I'm taking all the invoices, mapping them to work hours, summing all of them, and it should be 366 days times the work hours in a work day. Okay, and over here I have a similar test, but not for a leap year. 2022 is not a leap year, so it's 365. And over here, I'm also making sure that no day is a work day, and therefore the number of work hours should be 0. Okay, super, super simple. One dependency that you need to fake. Very, very beautiful test because they test just the core of the application. All right, so finally, let's go back and show you the monstrosity that is the core.